Okay, here we go. Chapter 7.2, Right Triangle Trigonometry. This is page 4 of the notes. And it looks fairly empty, but we have plenty to do. So in each of these, it's asking us to solve the triangles, which means we've got some information, but not all. And we need to come up with other angles, other sides, and go from there. Okay? So first things first, taking a look at triangle ABC, we've got that right angle at C, which is 90 degrees. We know that angle B is 39. So we know that A, and I'm going to stick it over here. Let's see, 6A. Angle A plus angle B has to be 90 degrees. All three angles have to add to 180. C is already 90. That only leaves 90 degrees for A and B. We know that angle B is 39. So I got A plus 39 equals 90. So the measure of angle A is 51 degrees. Okay. Boom. Okay. Next thing we're going to do is solve for side B. So let's remember that we can label the sides opposite the angles with the same letters, just lowercase. And so I have the hypotenuse. The hypotenuse is this 15.9. And so let's see what happens when I set this up. The sine of angle B, which is 39 degrees, is going to be the length of the opposite side over the length of the hypotenuse. That's doable. I am going to multiply both sides by 15.9. So I eliminate it down here. In the future, I won't show every single step, but I want to make sure we're not missing anything right now. And I'm going to flip sides here. That means that B is 15.9 times the sine of 39, which is approximately 10.01. Notice something really quick. I'm carrying this to 2 decimal places. The original number that I had over here for the hypotenuse, this 15.9, goes to 1 decimal place. Any answers that I find should be precise to 1 more place, so 10.01. Okay, and that is the length of side B. Now we need to find the length of side A. 2 ways we can do this. We could use sine again and do the sine of 51 equals A over 15.9. That is fine as long as you're convinced you haven't made a mistake. It would be possible also to do the cosine of 39, because that's going to be the exact same thing, A over 15.9. Okay, same thing here. We're going to multiply both sides by 15.9 so that we can eliminate that denominator. I get A equals 15.9 times the sine of 51. Notice I'm very careful to put that 15.9 out front. Round it to 2 places, we get 12.36. B. Same thing. We have one side and an angle. So we're going to start by finding the measure of angle B. So A plus B is 90. I know angle A is 19. So the measure of angle B is 90 minus 19, 71 degrees. And let us, excuse me. Sorry about that. Always comes in twos. So the measure of angle B is 71 degrees. Okay? And so now we're going to set up the same way we did before. We've got the sine of 19, and let me label these other 2 sides. There's my side C and side B. Sine of 19, that's our 19 degrees, equals opposite over hypotenuse. This time our hypotenuse is unknown, so we're going to multiply both sides by c. So these cancel. I get c times the sine of 19 equals 4. I need to solve for c, so I need to divide by the sine of 19 on both sides. It looks a little funky. Sine of 19 is just a number. I get c equals 4 over the sine of 19. When we take that to two places, we get 12.29. And so there is our hypotenuse. Okay. So to find side B, could use the Pythagorean theorem, but on the off chance I made a mistake finding C, I now am using an incorrect value to find another value. So I am going to go ahead and use what we have. Let's go the tangent of 19 equals opposite over adjacent, so 4 over B. That means B there equals, multiply both sides by B, divide by tangent of 19. B equals 4 over the tangent of 19. And when we round that to two places, we get 11.62. There's B, which my highlighter's a little too dark. We got A in the purple. Okay, so now it's time to take a look at C. And C I'm going to do over here on the page. First things first, I've got two sides, no angles. So I tend to use Pythagorean theorem first to find that third side. A little easier sometimes than the trig functions. So we've got, 11 squared plus 14.2 squared equals our C squared. When we multiply those out, I get 121 plus 201.64, so I get 322.64 is C squared. So the length of side C is 17.96. Again, I'm carrying that to one place more. Than what I was given originally. Okay, so this looks a little different. We have not used sides to find an angle yet. So here's what we're gonna do. We are gonna go, I'm just gonna set this up. And since I was given the 11 and the 14.2, I'm gonna start with angle A. The trig function that uses the opposite side and the adjacent is tangent. So I'm gonna set that up. Tangent of A equals opposite over hypotenuse. And notice I left myself a little room here. So we are going to use, we got to have something to undo the tangent. And so if you take a look at the calculator, we haven't focused on that a whole lot. If you're using that TI-84, we have 3 trig buttons. We've got our sine right here, we've got cosine, and we've got tangent. And you notice right above them, they have the same trig functions with that, looks like an exponent of -1. That means the inverse. So when we use sine, it's because we have an angle, we're trying to find the ratio. When we use inverse sine, that means we have the ratio and we're trying to find the angle. And that's exactly the situation we have here with this tangent. So what we're going to do